So let's look at multiple linear regression. And this is a continuation from simple linear regression. Remember, this is a type of linear regression, meaning that the relationship between the variables is linear, meaning that it's a straight line kind of relationship. Then multiple means that we have more than two variables. Of course, in our case, we'll always be having one dependent variable and more than one independent variable. For example, so let's consider this. Consider the regression of, let's say, y on x and z. So you may be told to regress y on x and z. So clearly here we have three variables. And I would like you to note that in this context, we'll only be restricting our discussion to maximum of three variables. So we'll either be discussing simple linear or multiple linear with only three variables. So if this is what you have, then you know that this is your dependent variable. And these two guys here are your independent variables. So you are regressing the dependent variable on a set of independent variables. So in such a case, the required regression equation is of the form y is equal to beta naught plus beta 1 of x plus beta 1 of z. So that's the required regression equation where y is your dependent variable, then x and z are the independent variables. Just like we explained earlier, beta naught, beta 1, and this beta 2 are the regression coefficients, or they are the regression parameters, and they are always unknown. So beta naught, beta 1, and beta 2 are regression parameters, and they are always unknown. Okay, they are always unknown. So if they are known, it means that we can only estimate them using some appropriate methodology. And just like in the case of simple linear regression, we can use the OLS method to estimate the parameters beta naught, beta 1, and beta 2. And just like we saw, we can we need to minimize some sum of square of some errors. And by so doing, we'll be having some function, which I don't want to write explicitly, which will be a function of beta naught, beta 1, and beta 2. So this is a function that I want to minimize. There's a function that we want to minimize. And for us to minimize this, these are a function with three unknowns or three variables, beta naught, beta 1, and beta 2. Meaning that when you have two independent variables, it means that you have three unknowns, and thus you're going to have three normal equations. So when you have three variables, you'll also have three normal equations. And these are the normal equations. So the first normal equation is as follows. And the approach of getting the normal equations is the same like the approach we used in the simple case. Remember, these are the model that we are trying to achieve. Y is beta naught plus beta 1 x plus beta 2 of z. So the first normal equation, you sum every term in that equation, and you'll end up with summation of y is equal to n beta naught plus beta 1 summation of x plus beta 2 summation of z. That's the first normal equation. Okay. And the second normal equation, you will take the first independent variable, multiply everywhere. So you'll have x, y is equal to beta naught x plus beta 1 x square plus beta 2 x z. Then you sum that. So you'll end up with summation of x, y is equal to beta naught summation of x plus beta 1 summation of x square plus beta 2 summation of x z. So that's the second normal equation. Now, the final normal equation, you will take this guy here, z, multiply everywhere by z, so you'll end up with zy is equal to beta naught. The reference point is always the first equation, z plus beta 1 xz or zx, consistency, zx plus beta 2 z square. Then you sum that, you sum every term, you'll get summation of zy is equal to beta naught summation of z plus beta 1 summation of zx plus summation of plus beta 2 plus beta 2 summation of z square. So those are the three normal equations that we need to solve simultaneously. So we say solve this simultaneously, solve this simultaneously, to obtain estimates of beta naught, beta 1, and beta 2. So I believe at this point, you know that these normal equations are coming from some process of differentiation. So you do some first derivative equal to 0, some partial derivatives, then you equal to 0. So you end up with these three kind of equations. It's like you differentiate with respect to beta naught equal to 0. Differentiate with respect to beta 1 equal to 0. Differentiate with respect to beta 2 equal to 0. So you end up with these three normal equations. Which one solved will give us the values of beta naught, beta 1, and beta 3. Okay, don't know if there's any question before we look at an example. So let's look at this example where you're told to find the regression equation of x1 on x2 and x3. Okay, so it's good for you to note that when you have a question like that, then this is your dependent variable, and these two are your independent variable. So in such a case, we need an equation of the form x1 is equal to beta naught plus beta 1 x2 plus beta 2 x3. Okay, so what are the normal equations corresponding to that? The normal equations corresponding to that, the first normal equation will be summation of x1 is equal to n beta naught plus beta 1 summation of x2 plus beta 2 summation of x3. In the second normal equation, you multiply everywhere by x2, then you sum. So we'll have summation of x1, x2 is equal to beta naught summation of x2 plus beta 1 summation of x2 squared plus beta 2 summation of x3 x2. That's the second normal equation. And the last normal equation, you multiply everywhere by x3, then you sum. So this will be summation of x1 x3 is equal to beta naught summation of x3 plus beta 1 summation of x2 x3 plus beta 2 summation of x3 square. So you need these values, summation of x1, which will come and get from here, summation of x3, summation of x1. N is the number of observations, 1, 2, 3, 4, 5, 6, n is 6. Then summation of x2. Then summation of x3 will be here. Then you need another column for x1 times x3. So we create an additional column there for x1, x3. We already have x3, summation of x3. We need another column for x2 and x3. And another column for x3 cube. I think I skipped this. We also need a column for summation of x2 square. Okay, so this is x3 square, not x3 cube, and so on and so forth. So you need to obtain these summations, you plug them in, and once you do that, you will end up with some 3 simultaneous equations. you'll end up with some 3 simultaneous equations. Maybe you can write them down. So I want to illustrate how these products and summations can be obtained quickly using Excel. So I need to multiply. So this is the data that was given in the question, x1, x2, x3. Then I need x1 times x2. So I just say this is the same as this times that, x1 times x2. Then you sum that. Sorry, you drag that formula. Then I need x2 square. So this will be this value here, raised to power 2. Then I apply the same that formula elsewhere. Then this will be x3 times x2, x3 times x2 is the same as x2 times x3. Then you apply that everywhere. Then I need x1 times x3. So x1 times x3. Then you apply the formula everywhere. Then I need, finally, I need this guy square. So these are the values that you should compute in an exam setting. So you need to have these values. You need to have that table. Then I need to get the summation for each of these values. Just do auto sum. Then you copy this, apply everywhere. So those are the summations that I need in my analysis. Okay, let me see if I can copy this table and take it back to my whiteboard. So once you are given the data and then you have come up with a table like this, and you already have the normal equations, you plug in the values. So the normal equations that we need to solve are as follows. Summation of x1, which is here. So this is summation of x1. So these are the summation values, the ones down here. I'm summing the values in that column. So this would be 54 is equal to n, number of observations, 3, 4, 5, 6, 6 beta naught, plus summation of x2 is 48 beta 1, plus 102 beta 2. That's the first normal equation. The second normal equation will use x1, x2. So this is 339 is equal to summation of x2, which is 48 beta naught, plus x2 square, which is 494 beta 1, plus x2, x3. x2, x3 is 10 that 4 beta 2. And the final normal equation, x1, x3, which is 720, is equal to beta naught summation of x3, which is 102, plus x2, x3, or x3, x2, which is 10 that 4 beta 1, plus x3 cube, which is 2188 beta 2. So these are the equations that we need to solve simultaneously. We need to solve them simultaneously. And the quickest method to solve these equations is using, you can use the elimination method, you can use substitution method, but you can also use the matrix method, especially the Cramer's rule, to solve this. So you will check my other class recording for the Cramer's rule, but I want us to use elimination method to solve this. So I'll call this one equation 1, equation 2, and equation number 3. Okay. So sorry, let's use substitution method. So you can say from 1, and I want to express beta naught in terms of the other values. From Roman 1, we can say that beta naught is equal to 54 minus 48 beta 1 minus 102 beta 2, divide everything by 6. That is the value of beta naught. Okay. So you can call this equation number 4. Then you can substitute equation number 4, substitute into equation 2 and 3. So where there is beta naught in equation 2, you put that value. The same case with equation 4. So you will end up with 339 is equal to 48. Then beta naught, you write this guy, 54 minus 48, beta 1 minus 102, beta 2, divide this by 6. That's beta naught, then plus 494, beta 1 plus 103, 1034, beta 2. So once you simplify this a bit, you will get an equation with only beta 1 and beta 2. So you can simplify that later. So this will be equation number 5. Then you do the same with equation number 6, with equation number 3. So you'll end up with 720. I'm working with equation number 3 is equal to 102. Then here I have 54 minus 48, beta 1 minus 102, beta 2, everything over 6. Then plus what? Plus 1034. Yeah, 1034 beta 1 plus 2188 beta 2. If you simplify this again, you will get is an equation with beta 1 and beta 2 as the unknowns. So you can call this one equation 6. So you notice that equation number 5 and 6, these two equations, these are equations with two unknowns. With two unknowns. That is beta 1 and beta 2. So what you need to do, you need to solve equation 5 and 6 simultaneously, just like we did in the case of simple linear regression. Because in the case of simple linear regression, we had two unknowns, beta naught and beta 1. So in this context here, we also have two unknowns, beta 1 and beta 2. So use any method that is suitable for solving simultaneous equations with two unknowns to obtain the values of beta 1 and beta 2. Then once you obtain the values of beta 1 and beta 2, so once you get beta 1 and beta 2, of course, these are estimates. You use equation what? Use equation 4 to get the estimated value of beta naught. So when you do that, you will end up with you'll end up with the estimated values of beta naught, beta 1, and beta 2. Okay, so I believe that is something that you can do on your own. So, but I'll give you the answers that correspond to these values so that you can check whether your answers are correct. So once you solve the equations, you confirm that these are the correct answers. Those are the estimates of beta naught, beta 1, and beta 2. So in that case, the required equation is, or regression equation is, you say x1 is equal to 16.48 plus 0.39x2 minus 0.62x3. And of course, this is an estimated value. So you put a hat on top of x1. the estimated value of x1 or the predicted value of x1 is given by this equation. So how do you interpret the regression coefficients? Interpretation. We start with the estimate of beta naught, which is 16.48. And this just means that this is the estimated value of x1 when both x2 and x3 are equal to 0. In other words, when you set this guy and this guy simultaneously into 0, if you let them to be equal to 0, then the estimated value of x1 is 16.48. Now what about the estimate of beta 1, which is 0.39? So this means that when the value of x3 is held constant, when the value of x3 is held constant, comma, the estimated value of the estimated value of x1 increases by 0.39 units for every unit increase in the value of x2. Hope you got that. So when we're interpreting this coefficient here, we must hold this guy constant. So in other words, it's like we are reducing our problem into a simple linear case. So we hold the last variable or all the other variables constant, then we interpret the current variable. So when you hold x3 and all the other variables constant, then the estimated value of x1, which is our dependent variable, increases by 0.39 units for every additional unit for every additional value of x2. And in a similar way, we interpret the estimated value of beta 2, which is minus 0.62. You notice this is a negative value. So here we start by saying when the value of x2 is held constant. In other words, if you control that value, if the value of x2 is held constant, and you say that the estimated value of x1 in this case, because it's a negative sign, we say decreases by 0.62 units for every unit increase. The word unit increase here means +1. Unit is 1. So unit increase is +1. If you do +1 in the value of x2, or if you do +1 in the value of x3, and so on and so forth. So the estimated value of x1 decreases by 0.62 units for every unit increase in the value of x3. In the value of x3. So that's basically how you interpret regression coefficients. So I don't know whether there's any question. What you need to be keen with is the calculations, the simplification of these equations so as to obtain these regression coefficients. Then that is the interpretation. As we've seen, it's not very difficult. So after this, maybe the other step will be to check whether these values are significant, whether the value of 0.39 is significant, the value of 0.69 is significant, 0.62 is significant, but that happens somewhere else. It will not be happening in this class, nor in this session. That when you test hypotheses about the regression coefficients. Okay, any question? So I want us to stop there as far as multiple regression is concerned. If there are any questions, you can always forward them to me. Please notice that I've recorded longer videos and I've posted them on YouTube. So in case you need some clarification in some stuff, you can always check them out. Thank you.